Okay, so I finally finished my prime harmonic sequence generator, and this fucking thing was hard, and it took a lot of concentration, but I did it in one sitting. It's 98 lines long, and let me show you what it can do. Alright, so it can do the harmonic sequence, and it can do the prime harmonic sequence. Let's see. So let's do the harmonic sequence first. HS, we're gonna put 100. This means that it's going to create a list of the first 100 lists of harmonic sequence entries. I don't even know how to say that the right way, but there you go. That's what the harmonic sequence looks like. Each number in there represents a factor, and each of these lists represents a number. And the prime harmonic sequence takes this and turns it into a number. So you can translate it. I'm going to do now the prime harmonic sequence, 100 of them. And those are the numbers that these vectors correspond to. And I'm not really going to get into exactly how, but that's for a different video. This thing is so fast. What it does, I don't know, maybe I could make it faster, but I haven't thought of any ideas of how to make it faster. So put it in 1,000. I mean, that's pretty fast. Let's see how fast it does 10,000. Pretty fast. Let's see how much that is. That's a lot of numbers. 10,000 means that's 10,000 numbers right there. So not 10,000 digits, 10,000 numbers. Yeah, that's quite a lot, isn't it? And I've got one of these fast scrolling mouses too. Interesting, I like those patterns when you scroll past. Look at that. Very, very interesting. And that's what my sequence is like. It's interesting in those ways. Look at the patterns in the spaces. Wow, there's something cool about that. And I've got lots of more stuff to do with regards to this thing, but I'm pretty proud of it. I mean, I did this before, and it was really bloated and really slow, and it took up about 300 lines. Now I did it in 98 lines, as compact as I can imagine making it. I don't even want to make another change on this. I'm done, but it's pretty much as compact as I could make it and as fast as I could make it. And yeah, it's pretty cool. Whew, that's an accomplishment, I think. Nobody gives a crap. I invented a sequence and created a program that creates the sequence. Nobody in the world has any idea what the sequence is or what it's for or anything, including me. It's just an interesting sequence to me, but I do think it is an accomplishment, and I learned a lot of Python programming. Yeah, I guess that's all I have to say about that. Oh, there are a few more things. So I can actually find the nth number in any sequence, and this is really fast too. So I type in nth ph, and then let's find the 999th number. 3,315. Interesting. Now let's look at the nth h. That's just harmonic, not prime harmonic. The nth prime harmonic, the 999th prime harmonic is 0110011. So let's think about that. Let's get out the calculator. I don't know why I don't just do it in Python. I guess I could. Okay, so 0110011. That's kind of rhythmic. Okay, so that's 3 times 5 times. That's a 7. That was a 2, by the way. The 7, an 11, a 13, and a 17. 3315. There you go. That's how that thing works. And if you want to look at, let's look at the HS. Let's go to 30 and watch how they work. So 1 becomes 0, 1. At that point, it says, well, we have filled up that space, but we don't yet have that many elements total. So we're going to make it 2 because there's two elements. So we're going to make 2 factors. So we make it 2, but we have to go to the minimum, which is by putting them all to the left, makes it just 2. And then we take 1 from there and move it over. And then we take 1 from the left and move it over again, 0, 2. At that point, we have completely filled up the two element vector. And now we are going to add a new element. But once we've done that, we have to add one more. It's God, it's so complicated what it does. That's why it takes 98 lines of code that are pretty complicated. And but why is this? What's the relevance of this? Well, I have found that with that really complicated code, it actually will lead you to Pascal's triangle, because you take different sections of this. Oh wow! I didn't know I could do that. Hey, I'm gonna figure this out too later. So that's a 1. That's another 1. That's another 1. It's a little hard to explain why. That's a 2. So you've got your 1s and your one of the 2s. That's a 1. That right there is a 3. So there's your 3. You know, Pascal's triangle is 1, 2, 1, 1, 3, 3, 1. The second 3 is right here. This was another 1. There's lots of 1s. Here's another. Oh, wait, that's no. And then I think this is a 4. Yeah, this is a. Wait. I don't know. I'm really tired. I've been up all night doing this. I'm really tired. But yeah, that's pretty much how it works, I guess. You'd have to study. I'd have to teach you exactly how the sequence works in the first place. But there you go. I can indeed make the sequence as long as I want. I don't know how far this thing can go, but I bet it can just go all night long and burn the computer up. I don't know. I am done.